Welcome to my new calculus channel. My name is John Gabriel. So I've been trying to state a particular theorem using the correct wording, and 2 times I've failed. But they say the 3rd time is always a charm, isn't it? Excuse me. So I'm going to try again the 3rd time and see if I can state it correctly this time, and simply enough so that you can verify it also with your bogus calculus. Okay? So let's begin. Now, in the new calculus, a definite integral is defined as the product of 2 arithmetic means. Did I say that correctly? Yes, that's right. The product of all the arithmetic mean of all the line lengths in a particular area multiplied by the interval width gives the entire shaded area. Okay, so what the theorem says is this. Okay, this is what the theorem says. If f of x, this point here or any other point on the graph, is a point on a nonlinear curve, and this area here changes with equal distances, like this, see, like that, on either side of this ordinate, this broken line ordinate f of x, then this ordinate here also has, well, it's actually at an inflection point, so I still didn't manage to state it correctly, but it's at an inflection point if this ordinate here is also an arithmetic mean of all the ordinates in this interval. Okay, so obviously this one here can't be an arithmetic mean because the arithmetic mean is shown in the red here. So watch here, if I change the distances, the arithmetic mean is very different, isn't it, to that particular point. And even though it's different, the areas on this side of the red dotted line are not equal, therefore it cannot be an inflection point. Whereas for this particular point, the areas, the distances here on either side of the point are equal, okay? And the ordinate, which is of length 4, this line length here, this length of this line is 4, remains the same, okay? It remains the same. It's always an arithmetic mean, and because it is an arithmetic mean and the distances keep the same arithmetic mean for the area, regardless of how they expanded or contracted on either side of the blue point, it follows that this point here is an inflection point also. That is what the theorem says. And it works regardless if you shift the x-axis up or down, and also if you shift if you shift the graph horizontally. Okay, it stays the same, right? Nothing changes, right? So it's an interesting theorem. It has some interesting properties in higher dimensions, which I'm not going to share. But if you study the new calculus and you really want to learn these things, it's possible that someday you might discover what those are. There are many new theorems in the new calculus, and you'll never know them unless you study the new calculus, which is the first and only rigorous formulation of calculus in human history. I'm rather tired now, so I'm going to end off. This is a new calculus channel. My name is John Gabriel. Till next time, goodbye.